Now, of course, please remember. No, not remember. Oh, you're going to be writing a quiz, second block. That quiz is all graphing. So, we will open with practicing a little bit of graphing because it also helps me do what I want to do next. So, let's graph these bad boys. Everybody go ahead and get started. Remember, you can graph any way you like. If you want to use tables of values, use tables of values. I personally put them into slope-intercept form. I find that the quickest and easiest way to go about doing it. So you go ahead, you graph these, I'll graph these, and we'll go from there. Go. When you have a solution, don't yell it out, just write it down. Everybody should have a solution by now. And what is it? 3, -4. Absolutely right. Okay, so remember yesterday I told the story about why, every year every kid tells me change the order that you do things, and well, I didn't today. So, everybody pick a number between 1 and 10. Don't say it out loud. You've got your number? Everybody's got their number between 1 and 10? Write it down right there. Do not say it out loud. Then do that. Okay? Go. Most of you should be approaching done by now. And of course, what did you find? Or maybe we're not done yet. And of course, what did you find? Or maybe we're not done yet. That's the nice thing about having 5-hour days. Attempt number 3. And what did we notice? Oh, well. I got coffee. I got crosswords. You guys tell me when you're ready to tell me what you noticed. Still nobody can tell me what they noticed, eh? So nobody was able to multiply an equation and solve for y by the second to last day of grade 10? Second time through for most of you? Oh, thanks, Madeline. There we go. Indeed, of course, it stays the same. I'll be doing that all day, so if you expect to finish the course, I expect somebody other than Madeline next time to say something. Now, if it stays the same equation, then what will the line look like? It will be the same line. Madeline, you can take a break. You're getting your A. Don't worry. There's 28 others. So what does that mean for us? Multiplying both sides of a linear equation results in a new equation with the same characteristics. What that means for us is we can change the appearance of a system, but not the solution. Turn the page over. Add those equations. We've added equations already this year. What will I get when I add those? 9x. What will I get when I add those? 0y. What will I get when I add those? 27. What should I do every time I see a math expression that looks like that? Isolate x. X equals 3. Now, I said put that on the grid above. Please notice, x equals 3 is this line right here. What do you see? It goes right through the solution, doesn't it? What happens? Well, adding the equations, what happened? The y value dropped out. And the remaining x value is half of the solution. Now, what would happen if I were to subtract these? What's 4 minus 5? Negative x. What's 3 minus 3? Plus 6y. And what's 0 minus 27? Negative 27. Now, if I solve that, y equals 1/6 x minus 27 divided by 6 is 4.5, right? Now, if I go ahead and I put that on the grid, minus 1, 2, 3, 4.5, and I go up 1 and out 6, what do you see happen there? Cross through the solution again. So, adding or subtracting two linear equations results in one of two things. One, you can eliminate a variable, or two, you can get a new equation that again has the same solution. So what does this tell us? I can multiply either of the equations. I keep the same solution. If I can multiply the equations, can I divide the equations? Of course I can. So if I multiply, I can get a new equation that keeps the same solution. If I then add equations, I can eliminate a variable, which is the whole reason we're doing this, right? We can't solve a system because there's too many unknowns. The third thing you can do is you can get a third equation that keeps the same solution and very possibly is easier to work with. Does everybody understand? What is the short version of what you have just learned and seen? You can make the equations in your system look different, but keep the same properties. And if they look different, they might be easier to solve. Everybody cool? All right. So let's look at that system I've given you right there. Write another equation. There's two. I want a third equation that will have the same solution. Everybody's going to write an equation right now, and everybody's equation is going to be different. So everybody write one equation. You now know three things you can do to write a new equation here. Everybody do one of them. And then in 40 minutes, somebody will volunteer their information for me. Well, no, because 40 minutes will be into the break, and nobody's going to do work on the break. All right, who's got an equation for me? All you had to do is one of the three things you just did. Okay, Madeline, hit me. Absolutely correct. Somebody give me another one. Pavni. Equals 36. Somebody give me another one. $72. Now, everybody's done the same thing. I said there were three options. Give me one that isn't multiplying. Good. Give me another one. This is wrong. No, this is right. Yeah, carry on. 4x. $19. This one's wrong. Why is that one wrong? What's 2 minus minus 1? Now, you now have 1, 2, 3, 4, 5, 6, 7 different equations that you could work with. That all will give you the same answer. That's the whole point. If the equations don't look nice and don't play nicely together, you change the way they look. How do you change the way they look? by adding them, subtracting them, or multiplying or dividing them. Does everybody understand? All right. Turn the page over. Let's go through elimination. We'll do all the steps in color codes again. Step 1, add or subtract. Step 2, solve for the remaining variable. Step 3, plug that variable in to find the other variable. And what is step 4 that I don't write, but I found I have to write now because kids refuse to do it? Check. Because is there any need to ask me to check over your work? No, because math gives you the answer. So let's look at this first one. Add or subtract the equation to get rid of one letter. Where is there a letter I can get rid of here? I can get rid of y. Why can I get rid of y? Because the coefficient is the same. It doesn't matter if it's positive or negative. Okay, since they are opposite signs, what are we going to do? Add or subtract? We are going to add. So in blue, when I add, what is 3x plus 4x? 7x. What is negative 9? They're going to drop out. What is negative 9 plus 23? I'm actually going to write 0y. What's negative 9 plus 23? Equals 14. Now, then we solve for the remaining variable. So that becomes 7x equals 14. Then what? Then we plug that remaining variable back in to find the other variable. Where can I put that? Anywhere I see an x. Who decides which x I put that in for? You do. It doesn't matter which one. If you put it in the top one, you're going to get 3 times 7 minus 5y equals negative 9. You're going to get 21 minus 5y equals negative 9. You're going to get minus 5y equals negative 30. And you're going to get y equals 6. Right? If you plug it into the other one, you're going to get 4 times 7. My pen is dying. Plus 5y equals 23. 28 plus 5y equals 23. 5y equals... what did I do wrong? 3x. 3. I put 7, not 2. What an idiot. Holy. I like how it took you guys that long to stop me. That's okay. It's the morning. Negative 5y, because x was 2. So 6 minus 5y equals negative 9. Y equals negative 15, or negative 5y equals negative 15. Y equals 3. Now, back over to here. Where were we? I did 7 again like a moron. 2, which is 8. So that is 5y equals 15 and y equals 3. Again, the point I am making is that it doesn't matter which one you use. You get the same thing, which gets me a final answer of 2, 3. And then I check it. What is 3 times 2? 6. What is 5 times 3? So 6 minus 15. Is that negative 9? Of course it is. What is 4 times 2? What is 5 times 3? Is 8 plus 15, 23? Of course it is. Now, let's pretend that you don't have 28 sets of eyes watching you do your work. Because you don't, do you? Let's pretend you looked at that 7 like I did, saw 7x, and put 7 in here, and did all the work, and got y equaled 6, right? Where would you find your mistake? When you did this. And then you would know you would need to change something. And you would go back and look, right? Would I have caught my mistake, even if I didn't do the second one over here? Because that's when I noticed I had made a mistake, because this was not going to come out to the same. But I wouldn't have done a second time. I would have just done this first one. Then down here, I would have used 6, and I would have had 6 minus 30 is, oh, that's not right. Okay? Okay. Let's look at the next one. What's wrong with this guy? Nothing's going to disappear, is it? So I need to change the way it looks. The best thing to do is to make the coefficients the same on one variable. Does it matter which one we do? If I multiply the top variable or top equation by 3, could I solve this? Yes. If I multiply the top equation by 2, could I solve this? Yeah. If I multiply this top equation by -3, could I solve this? Right? Does it matter which one I use? Who would like to tell me what I should use? -3, 3, or 2? I want to use -3? Badass, Damon. All right. Now, that's going to give me a new equation, right? You guys are lazy. You'll try and cram this in somewhere else and it'll be ugly. Don't. Write your new equation right down here. What is -3 times x? -3x. What is -3 times -2? Positive 6y. What is -3 times 7? -21. Now, should I add or subtract? I should now add, shouldn't I? So, what is 3 plus -3? Gone. What is 4 plus 6? 10y equals, what is 1 plus -21? 10y equals -20. Jeez. What is y? -2. Now what do I do? Plug it back in. Where? Anywhere I see a y. It doesn't matter. I'm going to use the second equation. 3x plus 4 times -2 equals 1. 3x minus 8 equals 1. 3x equals 9. X equals 3. Then what? Check your answer, because my answer right now is what? 3, -2. So now I check. What is 3? What's -2 times -2? 3 plus 4. Is that 7? Yes. Is 9 minus 8 1? Why didn't I write down that one? Because that's the one I used right there. Do I need to check it? No, because I've already done that one. That's how I got my answer. So I really only need to check the other one, don't I? All right. What's wrong with the third one? I have to multiply both, don't I? I need 2 new equations. What should I work with? 11 and 2 or 3 and 2? 11 and 2? If I gave you this, 1/11 plus 1/2 or 1/3 plus 1/2, which one would you rather work on? 3 and 2. because the common denominator is smaller, right? So I'll ask again, what should I work on here? 11 and 2 or 3 and 2? 3 and 2. What number is common to 3 and 2? 6. So if I multiply that by what? 2, what will I get? 4x minus 6y equals what? 40. What do I then have to multiply this one by? 3 to get 33x plus 6y equals negative 3. Now what will I do? I know it's hard to read because my pen is in the pooper. I don't know what is wrong with it. It's pissing me off. It's been bothering me all year, as you are well aware. Add them. You guys go ahead and add them. No, now it's really dead. He maintains his calm by getting his second pen, which also doesn't work. He maintains his calm by pausing the He maintains his calm by solving his problem and fixing the pen. Now, what was the added up to answer? What's 4 and 33? 37x, nope, still busted, equals negative 37, x equals negative 1. Now I take that and I plug it back in where? Anywhere I see an x. Should I use the top one or the bottom one? Top one, okay. 2 times negative 1 minus 3y equals 20. Negative 2 minus 3y equals 20. Then what? Sorry, that's we're adding. It's a positive 1, isn't it? So negative 3y equals 18. Y equals negative 6. What do I do with that? Plug it in where? Anywhere I see a y. Now, right now, I have 1, negative 6. Should I plug it into the top one? It doesn't really matter, but I've already just done the top one, right? So where should I plug it in? The bottom one. So that is, what's 11 times 1? 11. What 2 times negative 6? Negative 12. Is 11 minus 12 negative 1? Yes, and I'm correct. All right, listen please. Page 181, more practice. 182, another puzzle sheet. You will practice systems until the next, till the break. When you come back, you will write your quiz on graphing systems. in the number 2 spot there where it says systems practice, I'm going to force you to do the 2 puzzle pages that you didn't do. Because no one's going to do that second puzzle page because the answers aren't there. I'm going to force you to do both puzzle pages. And I'm going to put 3 extraordinarily challenging systems on the board. Okay? You will work on those. If anybody finds the answers, there will be significant prizes available. Of course, all that means is gummy bears. Because I don't know if you knew this, but you remember that stupid song, I'm a Gummy Bear? It's like its anniversary this week. Yes, I know. I'm as happy as you are about it. Okay? Go.